advanced simulation technology can achieve smart water management. We are currently experiencing a water crisis described as the worst drought in 1,000 years. With irrigators facing critically low water allocations, crop damage and increased consumer prices seem inevitable. The water crisis is seriously impacting on the nation, its consumers and producers alike. What if we can no longer draw water from the Murray? Can we sustain our water supplies? What if rainfall decreases by 20% due to climate change? What impacts will this have on our water supply and our economy? In order to address these questions, we need to look at the bigger picture. We need to make smarter decisions about large-scale, long-term water options such as infrastructure and policies. We also need to study the system as a whole rather than the sum of the individual components in isolation. Currently, our water options include restrictions, desalination, pricing structure, enhanced storages, stormwater and recycling. Ultimately, we can either use less, supply more, or manage better. Deciding which options will address the water crisis needs urgent attention. The problem is, managing our water crisis is complex. The system comprises many dependent components of water supplies as well as the users. The components display complex behaviours which include economic, political and social factors. For people to comprehend such a large complex system and its behaviours is extremely difficult without appropriate support tools. Intelligent software development's advanced software, Simulate Water, creates a virtual model of a water system including users, supplies and their complex behaviours. The technology is based on artificial intelligence and comprises individual software components that mimic elements of a real water system in a virtual environment. This enables testing of what-if scenarios for proposed water options and allow us to observe their expected outcomes before they are implemented in the real world. Software components in Simulate Water may be represented graphically. For example, the reservoirs, agriculture, industry and residential areas shown in this demonstration. The demo shows the varying water levels of the reservoirs as months pass over many years. Simulate Water can also present alerts of interest such as low water levels. The graphical output enables decision makers to gain better comprehension of the expected output as a result of the proposed decisions that they input into the system. This technology has been successfully applied in the defence industry. We've applied it to logistics to help move military resources more effectively, and in emergency response to identify new strategies for dealing with terrorism and natural disasters. Simulate Water has also been applied to urban water trading in collaboration with Professor Mike Young from the University of Adelaide. Urban water trading is one pricing policy that has been proposed to help manage urban water allocation. So in urban water trading, Simulate Water models individual households and their demographic characteristics. Each household is given a water allocation. Some households may use more, some may use less. Households that go over their allocation will have to pay a premium for their additional water. So through trading, households that use less can trade with those that require more. Simulate Water models the various pricing policies, household demand versus price, and quantity of water saved versus financial discounts given. Thousands of households may be modelled in a large-scale simulation to assess the effects of urban water trading in an entire city such as Adelaide. So using Simulate Water to analyse urban water trading allowed us to identify more effective modes of trading, which was previously not considered due to the complexity of the problem. Simulate Water looks at the big picture and simplifies analysis of a complex water system at the local, state and national levels. More water options and what-if scenarios can be tested, leading to better informed and smarter strategic decisions. Ultimately, the simulation will help address the water crisis effectively through better management of water sources and reduced infrastructure costs. So finally, we can either pray for more rain to solve our water problems, or we can use these decision support tools, which we now have available to us to help manage water smarter and prevent these issues in the future.